Buenos días, bienvenidos. Hello, everyone. We are going to be here for a couple of minutes, waiting for the 9 a.m., 4 p.m. in Dubai. Please wait, hold on for a minute. We are going to be connected with the Chilean pavilion in a few minutes. Vamos a conectar con el pabellón de Chile en Dubái en algunos minutos, así que los que se vayan conectando, por favor, nos esperen un poquito. Bienvenidos a todos.
Muchas gracias. Hola, Francisco.
Hola, profe. ¿Cómo estás?
Aquí esperando. Estamos todos en estado de espera. En waiting action.
Hola, buenos días. Por ahora hay gente de Chile conectada por acá, así que les hablo en español. Estamos esperando que activen la conexión desde la sala del pabellón de Chile en Dubái. Avisé ya al encargado del pabellón, así que esperemos unos minutitos. Había una reunión previa ya, y eso debe haber demorado un poco, por eso está un poco retardada la conexión desde allá. Ya avise. Vamos a esperar unos minutitos más, por favor, paciencia. Seguimos a la espera que la sala del pabellón de Chile conecte. Unos minutitos más de espera, por favor. Gracias por la paciencia. Bienvenidos a quienes están conectando a esta transmisión de seminario híbrido de ACHIDE. Estamos a la espera que se conecte la sala de conferencias del pabellón de Chile en Dubái. Así que les pido un poquito de paciencia. Disculpen esta demora, había una reunión previa en el pabellón y eso está retrasando el inicio de este seminario.
Hola Rodrigo, estamos en casa parece. Buenos días nuevamente. Les doy la bienvenida a todos quienes se han conectado con nosotros desde YouTube y también desde la plataforma Zoom. Estamos con alguna demora porque la sala de reuniones del pabellón de Chile en Dubái estaba ocupada en una reunión previa que se extendió más de la cuenta, así que estamos esperando que ellos puedan desocupar la sala y conectarse a esta reunión webinar por Zoom. Así que les pido disculpas por la demora, está fuera de nuestro control la actividad que sucede en el pabellón, así que simplemente esperamos con un poquito de paciencia que
ellos puedan conectarse con nosotros. Yeah, in case anyone from abroad is connected by YouTube, welcome to this activity. We are very excited to be part of this first experience in an international fair. We have a delay because we are waiting for the connection of the people of the Chilean pavilion in Dubai. So our apologies for that. Please be patient, stay with us. You are very welcome to be part of this exciting experience of international webinar. Please hold on for a minute. Hello everyone, hello Pedro and the teams. We are going to keep connected, waiting for the connection of the Chilean pavilion from Dubai.
Hola Karina, hola Erin.
Hola nuevamente. Del pabellón ya me avisaron que están tratando de conectar. Por supuesto tuvieron un problema técnico de último minuto que nunca falla. Eso no falla, tener problemas. Así que les agradezco la paciencia y les pido por favor un poquito más esperando la conexión.
Ah, está Pedro Serrano, qué bueno. Perfecto.
Estamos vivos. Hola Valentina.
¿Cómo están todos?
Hola, hola. Hello, everyone. Diego, dime si ya comenzamos. Let me know if we can get started.
Just 5 minutes, please.
5 minutes, okay.
Okay.
Ahí.
¿Cómo?
Apaga la música.
Puedes apagar.
¿Hay algún rebote en el sonido?
Mantengan los micrófonos apagados todos.
¿Ahí cómo me escuchan? ¿Se escucha bien?
Sí, perfecto. Ahí no hay rebote.
Perfecto. Bueno, me voy a poner para que todos me puedan ver acá. Aquí estamos. Okay, so anyone that no, I think that's people that don't speak Spanish, so we will need to make this event in English as it was planned. So welcome everyone. I'm Felipe Repeto, the Pavilion Director of the Chile Pavilion. Welcome to the Pavilion, for those who are here with us, and for those who are joining us from other parts of the world. I think most of them are in Chile. Be welcome to this event. We'll have different presentations from ACHIDE, the Chilean Association for Space. So I will first would like to give the floor to Mrs. Loreto Moraga for an introduction and then the presentation of the different speakers. Thank you.
Thank you very much. Good morning, good afternoon, good evening, anywhere in the world you are connected to this event. We are the Chilean Space Association. We are a non-profit entity in Chile. Our members are professional and students related to the space. They are studying something related to the space or have experience working in something related to the space. Our goal is to promote and develop the space activities in Chile. And one of our projects had been working with the Moon Village Association, with a program. Its name is Space Emerging or Emerging Space Countries Program, PESC. Because we are a Latin American country, had been some steps behind of this world of business space activities. And we don't want anymore to be behind. We want to be ahead now. We want to be a leader in the region. That is our expectation. We are decided to now not be anymore a witness, but to be part of this new kind of activities and economy. So let's get started. We are delayed, but now we are online. We are on a streaming by YouTube. So we expect to have an audience here connecting with us, learning about what is going on in Chile, what kind of ideas and projects we are developing here. So first of all, we are going to watch a short video with a short presentation of each of 6 projects. We have more than that, but these 6 projects are going to be presented today. First we're going to watch the video, and then we're going to leave the floor to each of the teams to introduce themselves, to present their projects. And after that, we are going to have a little conversation with all the queries and comments that you may have in relation to those projects. So you are very welcome to this activity. We are very, very excited because this is our first experience in an international fair webinar in this kind of hybrid connection with the people in the conference room and here from Chile. So first of all, the video, Sebastián, please go on.
Thank you, Loreto.
Mm-hmm.
Let's start the video now.
Thank you, Sebastian. So let's wait just a couple of minutes.
What if we could detect the first electromagnetic waves of the universe? What do we need? We need to get out of the Earth. We need to go to the moon. Some special location at the moon? Yes, at the lunar South Pole. Why there? Because at the lunar South Pole there are perpetually shadowed craters. We want to install a UVLF radio antennas inside of those craters you are seeing now. we have chosen a 20 kilometers diameter impact crater. Let us introduce you to the Shackleton's crater. At the left, image taken by United States NASA's LRO probe over the surface of the bottom of the crater by laser telemetry. The videos you saw previously were taken by Japanese Kaguya JAXA's probe in Selene mission. This is a 3D model of the Shackleton crater, a UVLF radio antenna concept with drive storage, data, and laser transmission capability. This is a papercraft model of a crater. At the surface of the bottom of the crater, there are several UVLF antennas to detect the redshift 21 cm hydrogen atom radio signal from the dark cosmic era of the universe. This is the first orbit of the lunar mothership. The second orbit of the lunar mothership deploys the antennas to the bottom of the crater. Now, the antennas are in the bottom of the Shackleton crater, in the shadowed area. This is the third orbit. The mothership catches the sunlight for stored electric energy and deploys that energy to the antennas by microwave cannons. The antennas store the energy and use it to upload the data collected by laser transmission in a subsequent pulse orbit. The mothership transmits the data to the Earth. This is a UVLF lunar project of Magellan Aerospace Industries from Punta Arenas, Chile.
A spacecraft is a means of transportation to take us from the Earth to some point in space. It's a workstation where the limits of the scientific studies are expanded, and in this new era of space exploration, now more than ever will become a living space, a home between the stars. In the workshop Journey to Mars, we explore, as architects, how this new phase of space exploration will be, through a deep investigation of space travel, and how this is integrated and transformed by the principles of the design of living space given by architecture.
Thank you very much. Thank you, Sebastián. You have seen now an overview of the projects. Now you are going to have the opportunity to meet the teams. So we are going to first start with the project of the moon bike. Martin Potters, are you there? There you are.
I'm here.
Okay, the floor is yours.
Thank you very much, Loreto. I'm going to share my screen. First of all, good day to everybody. Good morning here in Chile. Good afternoon there in Dubai, and to everyone around the world that might be watching this this interesting presentation of ACHIDE and the Chilean projects for the near future. Our presentation is on behalf of ACHIDE, as we said, also on behalf of the University, Technical University of Federico Santa Maria here in Santiago, in Chile, in Valparaiso, and the company NOT. We are developing this project on behalf of the Moon Village Association, and our project seems to be very basic. It's called Moon Bikes Project. It's a project to use bikes on the moon. Why should we use bikes on the moon? I will explain a bit more using this presentation. Basically, I'll be passing the video you just saw, but explaining a bit more on what we are working on at this very moment. First of all, my name is Martin Potters. I'm a Dutch aerospace engineer working here at the Academia de Ciencias Aeronáuticas, the Aeronautical Science Department of the Santa Maria University here in Santiago. Living and working in space on the moon, on Mars, seems to be very fun, a lot of fun and very easy. Why? Well, we experience low gravity, our body feels lighter, things don't weigh as much as it does on Earth. We can lift a heavy suitcase with just one finger. I imagine that everybody there in Dubai has brought some suitcases with them, 23, maybe two suitcases of 23 kilos, that's a lot of weight. But in space, this is a lot easier. Not only in space, but also on the moon. On the moon, in fact, we have only 1/6, as we probably all know, of the Earth's gravity. So we need a lot of less effort to walk around, to perform tasks that take a lot of effort here on the Earth's surface. But with less effort to do, there's also a problem because our body begins to adapt to the new situation that it's experiencing, just as it would be here on Earth. For instance, if you are climbing a mountain, if you want to climb Mount Everest, you need oxygen to reach the top, but you won't need oxygen to reach about 5,000 or 6,000 meters. You can do that escalating bit by bit, and your body will adapt to the new situation with less oxygen. And after a few weeks, you can simply move around as you did a few weeks earlier, but at sea level. The same happens in space. Our body starts to compensate the lack of gravity in this case. But this compensation, this adaptation of our bodies means that our muscles are starting to deteriorate. They lose their strength. On the left-hand side here, you see a normal muscle, the normal biceps. On the right hand, you see atrophied biceps, which means that the muscle itself deteriorates, gets weaker, gets smaller, and we lose the strength to do everything we can do normally here on Earth. The same happens to our bones. The bones stop capturing calcium, they weaken. On Earth, we have a disease, osteoporosis, which usually is a disease for people who have that condition. But living in space, living on the moon, this disease on Earth becomes normal because our bodies don't need any, don't need to perform any hard work, to say it that way. But this also means a danger to the well-being of the astronauts. If they fall over, they can easily break a bone, for instance. In fact, after a longer time in zero gravity or low gravity situations, the astronauts that returned from the International Space Station, for example, or before that, Mir or Skylab, had trouble walking around, had trouble functioning in a normal way. They needed several weeks again to adapt to the new situation back on Earth. They needed to regain their strength. They need to recover from their space journeys. The same will happen if we go to the moon, and if we go to space, and we will want to live out there. To prevent the weakening of our muscles, to prevent the osteoporosis, we need to do some exercise. That's the only way. We have already learned that, and in Mir and Skylab as well, and now in the International Space Station as well. The astronauts that are working over there are doing some physical exercise in their daily routine. It's absolutely necessary that they keep exercising, because if they don't, the muscles will weaken, as will the bones, as we saw just now. In this small video, you can see that it's not easy to walk around on the moon. It's there's low muscular sensation of the weight, and the others have difficulties sensing the inclination of the head. So we can't really find our equilibrium in this situation. It will be easy to fall over, and having a lot of weight above the waist level, because there's an air pack on the back of the astronaut, it will be easy to fall over. And if they don't have a lot of luck, they can break whatever bone they have in their body, causing obviously a lot of difficulties on the moon, where we don't have a hospital yet. The first astronauts even found out that it was difficult to walk, and it was a lot easier to jump around on the moon. The bunny hop like this was easier, 2 feet on the ground, more stability, but obviously the astronauts can't always go around jumping like bunnies. Sorry. We need something to move around if we want to explore the moon, if we want to go further away from the base camp that we will be having on the moon. In the past, also in the 70s, the first astronauts on the moon used a lunar rover to move around in medium and long distances. In the future, these astronauts will also need some kind of vehicle, a wheeled vehicle, to move around the moon's surface, which is very hostile to us. Obviously, the lunar rover didn't exercise the astronaut. It's just like being here in a car. People that drive a car and do not any running during the day, they will get obese, and they do not exercise their bodies. So thinking about all this, we started a project. Just let me lower it a little bit because you won't be seeing the text. Let me that way. So we decided to develop a new way of moving around on the moon, which is basically a moon bike. The moon bike gives us the opportunity to do some physical exercise while exploring, while working. The big question is, what kind of bike can I use? Because it's not easy just putting a bike on a rocket and get it to the moon. We need to develop a bike that withstands the hostile climate on the moon. We need to have a bike that will function in whatever condition on the moon. So it's a big question, what kind of bike? We can't have any motorcycle on the moon. We don't have oxygen for the combustion. An electric bike doesn't give us the exercise we need. A mountain bike will give some problems as well. So what kind of bike can we use? We started our conceptual design process with some brainstorming sessions. We thought about the lunar environment, the dust, the sand, the regolith we have there, the absence of an atmosphere, which is also a problem considering moving around. The possible movements of the astronauts, or better said, the limitations of movement of the astronauts. Astronauts can't move around just as easy as they would be doing here on Earth. It's not as easy for an astronaut to ride a bicycle as it would be here on Earth, for instance. And also the low gravitational conditions are a problem. We saw the astronauts jumping around. Well, imagine an astronaut on a bicycle. If he hits a rock, the bicycle and the astronaut will be flying around as well. And we need to address that as well. These brainstorming sessions led us to some basic conceptual design conditions, which led us to the following: to have just a bicycle with wide wheels for good grip on the lunar surface, and medium-sized wheels, so the astronaut won't be too high with the center of gravity. Seeing it as the whole combination of the astronaut and the bike must have a very low center of gravity in order to improve the stability of the bike and the astronaut. So the astronaut won't be falling over when he hits a rock, a small rock or a pebble. The bike must be stable. The astronaut doesn't need to fall. Just put his feet on the ground and can stabilize himself that way as well. These brainstorming sessions led us to some basic design conditions. We don't need any aerodynamic design. Here on Earth, it would be easy, it would be necessary to lower the air friction, for instance, to lower the drag. Well, because we don't have an atmosphere on the moon, we don't need any reduction of drag. There is no drag due to air. What's very important is that the bike is easy to mount. The astronaut doesn't have much mobility with his suit, so it's not easy to put his leg over the saddle of a bike like this. So we need a bike that is very low, easy to mount for the astronaut, and moreover, the bike must be easy to handle. There must be no restrictions in grabbing hold of the bike for the astronaut. We also thought of using a gear-based propulsion system to avoid complications with the chain. One would say, well, it's easy, just use a bike as we do here on Earth with the chain. But the chain provides problems as well on the hostile, within the hostile environment on the moon. The moon dust gets inside of the chain between the connections, which blocks the chain, which gives also problems that the chain can break. How do we can repair it? There on the moon, it's a lot easier here on Earth than on the moon. So you have to think about those type of things. So we came up with a gear-driven bike. Gears, various ideas directly connected to the rear wheel, for instance, or a double gear, dual gear. It's sort of a fail-safe connection. If one gear fails, the other still will be functioning. So our moon bike will remain functioning as well on the moon without the need to change it too rapidly. We thought of several connections as well of the gears to the wheels. We can connect it to the hoop, for instance, leaving the hoop clear, not using too much weight in this configuration. But we can also connect it to the wheel axis in a more traditional concept of a bike. Only the gear is different. The nice thing of this is that we can cover it all up because we need to cover everything up. And we also think of thinking of using a coaster type brake instead of hand brakes that are usually found on bikes here on Earth, because the astronaut will have problems using his hands with the gloves he has on, braking and hand brake. With a coaster type brake, it's simply moving back the pedals used for moving around, and the bike will brake. But as I said, we have to cover up everything because the moon dust will get into every part. We have to protect the whole bike, all the systems that we are adding on to the bike, which we will see in a moment. We have to cover everything up to protect it from the dust, from the moon dust we have there on the lunar surface. The pedal system we are looking into is a push type pedal. Also thinking of the mobility of the astronaut. Rotating pedals, which are usually used on a bike, are difficult on the moon because the astronaut with his big moon suit on can hardly move his legs, so it's not as easy to rotate the pedals as it would be here on Earth. The push type pedal is a lot more easy for him, just pushing down one and the other. This also means that we will have to look into the coaster type brake because moving back the pedal will be difficult because we don't have a pedal that moves back. But that's a problem that we have to look into and that can be solved in time. Already going into the preliminary design process, we also like to add a power system, not to move around the bike, but to provide electricity for several systems that we like to add to the bike. A power system with rechargeable batteries, for instance, to feed the frontal camera. So the astronaut can take pictures of where he's going. We can even, using telemetry, connect it to the base, so the base can look where the astronaut is going, stuff like that. We also need, for the darker sides of the moon, crater, for example, or simply if the moon is not lit by the sun in that moment, a complete lighting system, front light, rear light. So if there are several moon bikes nearby, the astronauts can see one can see the other where he's moving around. Also very important is an easy assembling and maintenance of the moon bike. The moon bike probably won't be going up in a rocket just as a whole, but in several modules. And these modules must be easy to assemble once they get to the moon. So easy assembling, and after that, easy maintenance is very important as well for the moon bike. If we have human settlements there on the moon for mining projects, for whatever project, and it's also very important that they know where they are. So the moon will need its own location service because we don't have a GPS, global positioning system, right around the moon. What we're thinking of is a location service based on several antennas, used for triangulation, just as aircraft here on Earth did, well, still are doing, to locate themselves using the help of base-mounted, Earth-mounted antennas. In this case, just a triangulation of antennas near the bases where we can move around. And from the base, we can watch where the moon bikes are, and the moon bikes can also position themselves. This lunar positioning system will be there. The astronaut will have a small monitor on his moon bike to see where he is, which way to go to return to the base. For instance, if he's in a crater, he won't have any idea where the base will be. Will it be this way, that way? The first time he gets into a crater, we'll see his marks of the wheels. But after several visits, the marks will be all over the place and it will be difficult to find the way back. So a navigation system will be absolutely necessary. Just like in aviation, we'll also think of using an emergency location transmitter. In case of an accident, the bike falls, the astronaut is hurt, automatically an emergency location transmitter will activate so the base can send out anybody to help the hurt astronaut in whatever situation he's in. And also a transceiver to indicate the current position, as we saw just now in the screen picture that showed before this one, to locate the bikes where they are, where the astronauts are, and maybe indicate them as well that they have to position them more to the left, to the right, or go to a certain spot on the moon. Up to now, all these concepts, all these considerations led us to a very first preliminary design, which you are showing in the picture right now, complying with everything we've seen up to now. This doesn't mean that this will be the final design, obviously. Our moon bike still needs a lot of work. We need a lot of development, testing, improvements. We need to see exactly where it will be used on the moon, where the bases will be located, what kind of lunar surface will be over there, how many slopes there will be it be easy for the bike to go up a slope, go down a slope. If it's very rocky around there, that will put extra conditions on the wheels. What kind of situations will we be using the moon bike, or the astronauts will be using the moon bikes? All of that are considerations that still have to be addressed and will be probably changing the preliminary design we have up to now. But definitely, we think that the moon bike will mean a versatile, a healthy way to explore the difficult lunar topography for the future settlers there on the moon. This was my presentation of the moon bike project on behalf of the university, ACHIDE, and NOT, No Ordinary Things. I'd like to thank you very much for your attention. And at the final stages, after the final presentations, there are some questions possible. So thank you very much. This was my presentations. Loreto.
Thank you, Martin. This has been a very interesting presentation of you. Well, next project is a Lunar Radio Telescope. Please, Mario, introduce yourself, introduce your team, and present your project. The floor is yours.
Thank you, Loreto. I will share a screen of a PowerPoint. My project is about a very low frequency radio antenna in the south pole of a lunar crater, a shadow crater. We have a team. I will share the presentation here that shows the people who are in this project. So, vamos a share presentation. Okay, vamos a share screen y vamos a ver si funciona, if working. A ver.
It's working.
It's working? It's working? Okay.
Yes.
Okay.
Please use the mode of presentation. Excellent.
Excellent. Yeah. Well, this is the team. The team is well, in the bottom of the screen. You are seeing now Francisco Arzúa Villegas from the right to the left. In the bottom photograph, Francisco Arzúa Villegas is a geographer. He's a specialist in GIS, geography in information system, and a specialist in other spatial matters. The other is Juan Almonacid Uribe. He's an astronomer in Punta Arenas, Chile. He observed the celestial the Celestial Valley from Punta Arenas about 4 decades ago. The other is Eugenio Bahamonde. Sadly, he's not with us now. He was a space investigator. The other is me, Mario Esquivel Elizondo. I'm a lawyer, and I created the initiative Magellan Aerospace Industries. That our objective is to promote and divulgation space matters and space activities to our community in the Magellan administrative region of Chile and the Antarctic territory of Chile. As well, the guy in the photograph of up in the upside of the screen is Yuki Takahashi. Yuki Takahashi went to us in Punta Arenas when he installed a radio telescope in the south pole of the Earth in Antarctica in the base Amundsen Scott United States base. And he told us about this idea that he had about to install a very low frequency radio telescope in the far side of the moon, in the south pole, in a shadow wave impact crater. Yeah. Another guy who support us is Yuri de la Barra. This not in the screen. He's a radio amateur and he's a member of the Chilean Air Force. Well, we propose, the objective of this proposal is to install radio antennas in the far side of the moon on the bottom of a perpetually shadow wave impact crater at the south pole of the moon to detect the first electromagnetic radio wave of the universe that come from the dark cosmic age. The objective is to detect the first electromagnetic wave of the redshifted 21 centimeter hydrogen neutral atom radio signal from the dark age of the universe prior to reionization era. Why? Because the dark age of the universe is the only epoch of time that astronomy can detect the electromagnetic waves from around of the Earth or from space satellites. It's very difficult because the radio interference from the radiation of the sun and interference from the radiation of the man-made radio waves from the Earth are the bounds of those first electromagnetic long radio waves at the ionosphere layer of the Earth that acts like a shield. So it's very difficult to detect this first electromagnetic wave of the universe from the ground. It's very difficult. So if there are no stars in dark age, from where are born those electromagnetic waves? Because we want to detect these first electromagnetic waves, but where they come from? Well, very briefly, the electrons that rotate in the outermost orbit of the nucleus of the atom have a greater amount of energy than those that rotate closer to it. As the influence made by the attraction of the nucleus of the atom of those electrons, in this case, is weaker, those electrons are the most likely to leave their orbits. When some alien particle collides with one of these electrons in higher orbit motion, the electron becomes excited, causing it to leave its corresponding orbit and occupy for a brief moment another orbit of a higher energy level further away from the nucleus of the atom to which it belongs. The immediate reaction of the nucleus of the atom is to attract the electron to incorporate it back into its original orbit immediately in order to continue maintaining a neutral electrical balance. At this precise moment, the electron returns to its orbit the extra energy that was acquired by this electron when passing from a lower level to a higher energy level orbit and back to its original orbit, released in the form of a photon of light. The extra energy released with a photon of light. So, born an electromagnetic wave. The photon travels like an electromagnetic wave, and the electromagnetic waves are the fastest moving thing in the universe. They move at the speed of light because they are light, photons, 3,000 kilometers per second, but they 300,000 kilometers per second. But they have other properties too. Wavelength and frequency. Wavelength is the distance between two successive peaks or throws in the wave pattern. Frequency is the rate at which these peaks or throws move past at a specific point. Because the speed of light is fixed, high frequency wave must have short wavelength, and low frequency must have longer wavelength. Yeah. the Doppler effect and stretching of the wave. Thanks to spectroscopy, we can detect the motion of the stars, a phenomenon known as the Doppler effect, causes a slight shift in the color of starlight towards the blue or the red end of the continuous spectrum, depending on whether it is moving towards or away from us. Edwin Hubble discovered that many galaxies have absorption lines in the continuous spectrum to the red wavelength, discovering the stretching of the wave while travel on the space-time. So more distant galaxies further away, more faster than the nearest to the Earth. So a stretching of the dark era photon, where it goes from gamma wave and is beginning to radio wave at the end due to its loss of energy during the long journey from 13 billion light years of space to us. So the wave born like a gamma ray, but it's so many space and so many time that's a wavelength stretching. Yeah. So come to us at the moon and in the Earth like a long radio wave. Radio frequencies emitted by the luminance emitted prior to the creation of the star in the dark age of the universe. Very briefly, the 21 centimeter line, the hydrogen line, 20 centimeter line, or H1 line, is the electromagnetic radiation spectral line that is created by change in this energy state of neutral hydrogen atom. You know that a neutral hydrogen atom is only a proton with an electron orbit around him. This electromagnetic radiation has a precise frequency of 1,420 hertz, which is equivalent to the vacuum wavelength of 21 centimeters in free space. But the redshift that I told you before, this line will be observed at frequencies from 200 megahertz to about 9 megahertz on Earth. It potentially has two applications. The first, by mapping the intensity of redshift 21 centimeter radiation, it can, in principle, provide a very precise picture of the matter power spectrum in the period after recombination. Second, it can provide a picture of how the universe was reionized and as neutral hydrogen, which has been ionized by radiation from stars, from the first stars and the first galaxies, and the quasars will appear as whole in the 21 centimeter background. However, the 21 centimeters observation are very difficult. That was, I tell you before, difficult to make for ground-based experiments to observe the faint signal are plagued by interference from television transmitters and the ionosphere that I told you. So they must be made for very secluded, isolated sites with care taken to limit interference. And that isolated site is the permanently shadowy craters that are located in the south pole of the moon. The epoch to study is from the 300,000 years after the Big Bang until 1 billion years after the Big Bang, that the beginning of the reionization era when the first star and galaxy formed. But well, the Hubble telescope takes a far galaxy, very far galaxy from 400 million years after the Big Bang. But well, it's discussable. Several other projects how to make headway in this area in the near future, such as the precision array for probing for epoch of reionization paper, low frequency array LOFAR, Murchison wide field array MWA, Gian microwave radio telescope, mapper of the IgM spin temperature MIST, the Dark Age Radio Explorer DARE mission, and the large aperture experiment to detect the Dark Age LIDAR. But these all are in the Earth, in the surface of the Earth. That's the problem. So the permanently shadowy regions, or PRS pole, this image was taken by our probe, and you can see this image and take it and download it by the NASA's Trek webpage. That's incredible page. That is very, very fun, very fun. And we detect and we know all the permanently shadowy regions in the South Pole that we can put a radio antenna in those areas. Yeah, as a shield, well, it's very useful as a shield against the sun radiation and earth radiation man-made object that I told you that they have radio quietness, VLF radio, as a platform for long interferometers area. Well, this is a picture that we taken from a video of Kaguya JAXA Select mission of Japan, and you are seeing now the Shackleton crater that we choose. Yeah. This is the Shackleton crater taken by RRO probe of United States, and you are seeing now the shadow of the crater, the permanently shadow crater. The light of the sun never reached this area, never. But with a laser telemetry of the RRO probe, the laser telemetry takes the surface of the bottom of the Shackleton crater. In the picture you are seeing now at the left of the screen. Well, this is a shape file of 3D model of the Shackleton crater that we download from the NASA STREC webpage. It's very useful. Well, this is the old studies about Radio-Lunar Observatory's proposal that study Yuki Takahashi. Yeah. Yuki Takahashi made a history registration about all the projects that astronomy projects that want to put a lunar radio telescope in the South Pole. Well, the mission. Some expect data of a low-cost mission. This is, well, with the team, we think about this. We know that it's very hard mission, it's very difficult, but we think that with a Proton rocket or Delta IV heavy rocket or GSLV Mark III rocket of India or Japan, we can put a first mothership with antennas about 2,000 kilos with 100 kilometers lunar orbit altitude. Yeah. Well, this is the first option is to put an antenna rectenna proposal. Yeah. The second option is to put an antenna nuclear energy proposal. And the third option is an antenna with solar panels outer of crater or the crater. Here you are seeing now a proposal of NASA of 2020. Yeah, it's really very rare, very strange, because when we interested in this project, immediately, well, I don't know why, but we know that NASA in 2020 had some proposal, JAXA 2, the Russians too. So there is a little race in the south pole of the moon between in what is the radio astronomy and in water. Well, this is the mission. The first orbit, the lunar mothership, orbit around the moon, ¿no es cierto? Over the Shackleton crater. The lunar mothership, when reach a Shackleton crater in a subsequent orbit, in the second orbit, deploys the antenna to the bottom of the crater, like the video you saw previously. The antennas are made like an interferometer in the bottom of the crater. In the permanently shadow away crater, they don't have interference from the sun horizontal light rays, and even of the man-made interference radio signals from Earth. Here, in other orbit, the mothership takes the sunlight with the solar panel to charge his batteries. And why? Because in another orbit, the lunar mothership beams the electricity by microwave cannon to the rechargeable battery that will be with the antenna to make functions the storage data, the laser uplink data, and other electronic systems. Yeah. Now, well, the antennas have a hard drive to store the data to upload in the next orbit pass of the mothership. Antennas have a rechargeable battery for laser uploading data to mothership in orbit. And in this time, the antennas laser uplink the data by laser, yeah, from the bottom of the crater to the mothership that acts like a relay satellite to send the data collected by the antennas to the Earth by radio waves. what are the problems? We know that it's a very ambitious proposal because many of these technology aren't developing in total development. For example, we know that the laser uplink data link only we have now 10 or 20 kilometers from point to point to point. We know that to beam electricity by microwave, like from a space-based power electricity system, is under development. Recently, last year, the Pentagon made some tests, but we hope that in recently time, this kind of technology will be more developed. But we have other problems. Three problems. The first, the internal lunar satellite constellation. Soon, Starlink will have a Starlink constellation over the moon. So it's impossible to put a radio telescope in the south pole of the moon if we will have a Starlink constellation of satellites around the moon. Yeah. Other problem is the ice water in perpetually lunar shadowy crater in South Pole is a race. It's a geopolitical race that all superpowers and regional powers of space want to have this water ice reserve in the bottom of the crater. So we are thinking, well, where we go? So, well, there is Ceres, is a minor planet that have perpetually shadowy craters too. So this is the presentation. I hope that you understand, and thank you very much.
Thank you, Mario. Very complete presentation. Please download your presentation. Thank you very much. Carlos Palma, are you ready from the conference room in Dubai for your presentation?
Yes, well, I will try to give a better experience for the people here because I am in Dubai. Someone will help me to show. You can see my presentation in the.
Not yet. We see you, the conference room, but not yet your presentation. There you are. Now we see the screen. We can see the screen, but not yet the presentation.
Now it's showing the presentation, right?
Right.
Yes.
The one time with the autocarrier in the front? Okay, great.
We are done. Yes, yes, please go on.
Okay. Well, thank you very much to be here. I will show you our projects for this Expo Dubai 2020. Our company is Grupo Biec. We represent a couple of firms from Chile to develop different things in industries like manufacturing and agriculture, right? Our company was born like 27 years ago, principally to manufacturing clothes for industry, technical industry, and to institutional different kind of clothes. And then the company will start to diversify their operations and then to start to develop some products in software, electronics, and another company named ACHIDE. It's dedicated to agriculture industry. Yeah. Our mission and vision of our company is principally to find the ways to do different things to generate and solve global problems. This initiative is very good because for us it's an impulse for making better things and more technological and efficient ways to solve different problems. The next one. Well, there is the description for our companies. The principal is the group for involve all the different solutions. The second is ACHIDE for the agriculture the different products. Principally focus in the development of seeds to produce for different kinds of food for agricultural industry. And we decide to participate in the Moon Village program with ACHIDE because we think it's the long-range distance of developed solution for the future. And that's our idea for the new products of the company. And why we decide to participate in the space industry? Because we detect in the world, we can find different skills that are important to develop the countries. For example, if you see these graphics, you see the biggest countries are a biggest investment for money for different space programs. In Latin America, that happened. And now probably could be the way to develop the country. The second. You can see in this slide the investment or the size of the space industry, close to $400 billion in all the world. And this industry is growing very fast. Another thing is important, it's many things in the space industry could change to be a commodity now. For example, the launch systems are cheaper than 20 or 30 years ago. The same thing happens with satellites or other things or other materials and technologies for this industry. Now, for that, it's very important to take the opportunity for the undeveloped countries like Chile. And that's the way we want to think, to the opportunity window, to capture this opportunity to develop the country and this industry in our region. Well, this industry have many problems to solve, principally the moon. We have to detect different problems to try to solve it. What these kind of problems we can solve? One of that problems is relate to the human body. The human body in the space have many problems of health. For example, you lost mass in your bones, you lost mass in your muscles, etc. And that is very important to solve if we want to go to the moon and stay a long time there. Other difference with the moon and the Earth is principally of the rules of play there, because in our planet we have an atmosphere to protect us for the cosmic radiation, and we have gravity, and we have temperature oscillation is low, like 50 degrees. And in the moon, in the next one, we can see in the moon we have other rules. We have thermal oscillation like 150 degrees. We don't have an atmosphere to protect us, and we have 6 parts of our gravity. and that is completely different conditions of design. And what kind of product we can develop for the moon? Well, we can develop products for the launching systems, housing, clothes, food, completely different products for these conditions of design. And well, our country have different conditions, and in their industries are developed, or we have a competitive advantage for other countries that never develop solution for that. And that's, I want to show you some ones, principally relates for the mining. For example, you can see in those images different conditions of mining in the north of the country. And in the next one, we can see other skills have our country with the natural laboratories. We have in the Andes Mountains very high places to make experiments for different conditions of the space recreation. And well, starting for this little bit of context about how our company decide to participate in this kind of projects, we start to work for something close to that problem. The first one for ACHIDE, we make us this question: what do we need to survive on the moon? That is a very mandatory question because the people need to eat there to survive. And the answer of this question is food. And we have technology and we have facilities to develop now, but solutions for the earth. Our company have 2 experimental stations in the country, one in Los Angeles, another in Temuco. We develop different kinds of seeds of the industry of food. For example, durum wheat seeds for the agricultures to produce pasta for the industry in the country. And now we want to develop these skills in other conditions of production. We have different kind of professionals, like engineers, like physiology of plants engineers. They are working in this kind of products. And we can use these skills in different laboratories with different conditions to test these seeds and test these plants. Our idea is to create a new conditions of laboratories placed in the Andes Mountains, very high, inside on an electrical energy power generation. These conditions are pretty good because we have a place to protect our experiments, and then we can do it in different conditions of high on pressure or weather too. That information could be very exciting to develop new kind of products to have the chance to survive in the space or in the moon. This information could be very useful for that, to have winners plants or winners seeds to could be developed there. That's some images for the different electrical plants in the Andes Mountains close to Los Angeles. And in the next one, we can start with the other product we have close to or relate to the manufacturing of garments. The company of us have a very long story about manufacturing clothes. And we start 5 years ago this project named Aura. Aura, it's developed thinking about mix electronics with garments. Thinking what? Thinking in the protection of workers. In different productions or different industries in the countries, the risk of the workers is very high, principally in the forest industry, in the mining industry. And this kind of technology could be used in the space. And that's our idea to develop this kind of clothes. For example, in the first slide you can see a mining vest. This mining vest I am wearing now too have different electronics inside. One of that is they have lights to protect or give visibility to the other workers or places they are working in the areas of manufacturing or in the mines. They have a system of communication to make a mesh network of different workers to make the transmissions of the information of the different sensors inside, and have position sensors like GPS and gas sensors. We can see in the next slide the other design of the same technology places in the forest industry. It's a little bit lighter than this one, but this is thinking about to work outside in the sun conditions, in the mountain, or in the harvest of different kind of plants in the forest industry. And some of the sensors we have inside, you can measure gases like CO2, very poison gases like formaldehyde, for example, or sulfuric acid. That is very poison. Its presence in the industry of petroleum, basically. Other of the garments we develop is a first layer t-shirt. I am wearing now this t-shirt. This t-shirt have two different sensors. One is a temperature sensor to the body temperature. Another one is electrodes to measure the ECG of the heart. This information for health is very important because you can identify the conditions of health of different workers in different situations. And that kind of information give us the possibility to interpret this data to produce new information for the company are trying to monitoring these workers. I will show you in the next one different kind of information we can predict with this data generated about these sensors. For example, fatigue. Using the ECG and using the temperature, using artificial intelligence, we can interpret this data and transform this information in new kind of information. Other kind of information we can generate is about the emotions. We can interpret this information about the electrodes and temperature sensors, and with different kind of algorithms, we can interpret the emotions of the people. We can see in this next slide how we can capture with the electrodes the signal. In the blue ones, you can see a lot of noise. With the different process of computer process, we can clean the signal, and you have the signal clean about your heart. This process is very important because you can produce different kind of information with the essential signal you are capturing. In the second slide, in the next slide, we can see some of our parts of our app we are developed. You can see the heart rate dimension, the ECG in real time. You can see the temperature of the body, etc. And the other part, you can see the generates of emotions in the moment about the interpretation of different measures of ECG and temperature of the body. This technology also can use in the moon or in the space to detect different kind of distance of the bodies of the workers, or in this case, the astronauts. if we can put it in the suits are developed for the astronauts, you can measure the distance of different astronauts and the astronauts with other machines. That example for the connections of the different machines and suits, and this it's a mesh network of information to transmission data and measure distance for the different parts of the components of nodes. That's one, it's another image about that to explain how the team system works, how you can place in the different parts of work the workers with the different suits, and that helped us to make and unveil this network. Well, that is a summary of the different skills we have developed of our IDT solution. We have a smart lighting, motion sense, gas sensor, security alarm, position in the world, thermometer, and safety distance detection. And the last slide for this solution, I want to show you this new developed for us. We take part of the technology are developed for the mining industry on the first layer, and we'll put it inside of a tactical defense vest. Yeah, that technology is it's developed for that because we think some skills of that can help for people are dedicated for defense. One of the difference of that is the way we alert different kind of distances of the soldiers in this case, because they have a vibration system, and this vibration system alert to the soldiers the different distance that we are making. In the second slide, we can show you how they sensors are located. In this moment, it's not working because you don't have many things working, but the system works in the same way of technology of the mining vest and the smart t-shirt with the electronic side. That's some images about the panel of control of the computer. You can see different things of the vest and the workers or soldiers in this case. And in the other slide, we can see part of the monitoring to identify some people with their different sensors are capturing information, etc. The other one have the same information, but some part of the global position to the GPS detection. And the other, you can see a diagram of relative distance. This one is made with the antennas inside of the car. And the last one, you can see a part of our application. This is a case made with us, with the company Arauco. We test the technology with in a forest industry to detect the workers in the field. They have problems of accidents for machines. They are making accidents because the people are too close working and they have damage with the machines. They put it a rule of distance to make to start alerts to different workers and in a central of operation. And we test in the plants in the 6th region of Chile, and the technology works very good. We don't have problems or don't have problems about interference or problems with the forest are too or the design of the geographic place in the area. the exercise was assessed. And we have the last idea to test this solution in the combat of fires in the forest. That's definitely the second way to prove it that, because the people of this area are to be exposed to different risk and higher risk to the other workers. We have in those years a very big network of connections with different other companies in telecommunications like Entel, Claro, and Arauco also. That's one of the parts of we are have the possibility to make better the technology and calibrate the different solutions for the different issues they have in the industry. And that's all of the presentation. Thank you very much.
Thank you, Carlos. Outstanding, very interesting. Now the floor is for Valentina Purcell and her team. Pedro Serrano, I understand that you are going to connect and introduce the team and the project. Pedro, are you there?
Yes, I'm here. Good afternoon, Dubai. And good morning for the Chilean people. My name is Pedro Serrano, member of Chilean Space Association and director of the team architecture unit of the Federico Santa Maria Technical University, Valparaíso, Chile, South America. The architecture of interplanetary space and the future of the architecture on the Moon and Mars are part of our investigations. We work in Antarctic, we work in the ice jumps, etc. We also explore and speculate in the design architecture of spaceships with all the conditions of human survival in time, travel through empty space, meteorites, impacts, cosmic solar radiation, artificial gravity. You can see that in the exposition, in our part of exposition in Dubai. I am pleased to present to you the final year project on mining on the Moon of architecture student Valentina Melo and Erin Flores. Valentina training mini astronauts in a Chilean analog location, and Erin deploying a mining establishment below the lunar surface, below the moon surface. Please, Valentina, you start.
Okay, hello everyone. Hay interferencia.
Please mute the rest of the people, please. There you are, Valentina.
Start microphone.
Space. This week we're talking about the space beyond the Earth. But what if we talk about the space that we can create? A space in the universe for us. We have done it, like the International Space Station, but we are moving forward. Our satellite, the Moon, rich in indispensable elements for new tech, like high tech. The lunar mining is indispensable area to be developed. The training of miners astronauts on Earth can be possible in analog territories like the high altitude underground mines. Chile can contribute on the aspect with our extended knowledge and our technological innovation of an underground mining. As architects, we can see like our possible second house that will help us jump other planets on the solar system. There are important topics to have to consider today. The today's space race, the global demand of raw material, the rare earth for technology developed, Chilean extended knowledge and technological innovation of underground mining, and our Chilean territories with potential to be used for simulation of extraterrestrial environments. But why use the underground analogous territories? Well, the extreme lunar condition on surface. There are three topics: the cosmic radiation that we can separate in the galactic and the solar. The solar can be manageable going underground. The regolith can protect us. And the aeroliths impacts, there are little meteorites that fall into the atmosphere of the moon. And the extreme temperatures. You can see the difference between the day and the moon and the night. My project is about the simulation in analog territories for the training for lunar astronauts in the underground. The underground mining, like we have in the El Teniente, that is from Codelco. That can be a really good place to develop this laboratory. This laboratory to train the future miners, astronauts. The mission will be the extraction of rare earths or the investigation, but here on Earth. We are not sure if we want to find rare earth on Moon, but we know we have here on the Earth, and they are more valuable than anything on this day. Here are the diagram, the general problem that is separated in three topics: the structural requirements, logistics, interior habitability, and, well, the structural requirements have to respond to the extreme land environment, the logistic, the ability to be transported and assembled, and the interior habitability, what is the design of ability in tight and hermetic spaces for long periods. We are thinking about 4 years to be in a mission, a long mission in the Moon. We designed a laboratory with terrestrial technology for the abandoned tunnels of the El Teniente mine in the mountain of Central Chile, with the installation analog to use on the Moon, operations with vacuum suites low temperature, water system, prospecting the roads, oxygen, toilets, and well, the energy. The diagram distribution, this is the first thing that the architect thinks to can develop the design, the complete design of the project. So we have the ground control module that can be monitoring the trainees, then the simulation module, then an airlock and a seatbelt. Next, you can see a concept. The simulation modules where they can investigate and where live, they're going to live there. The airlock that is in a pressurized module, and the switchboard. The video, the next video, the last one that
Está sin sonido, Valentina.
And now I'm going to show you the spaceships to Mars, the workshop that we have last year, Road to Mars. I'm gonna show you. Marching ship Artemisa 5. Can you hear it?
Yes, we can hear you. Yes.
¿Qué te amigo?
Luego se me...
Models in microgravity and Martian ship Artemisa 5. Find the distribution of the models in microgravity and gravity, we took as reference the daily routine of the astronauts in the International Space Station. We give a lot of relevance to leisure time because it's essential for crew's mental health. We took existing references for the design concept of the models. For the wall thickness, we took the thickness of the walls of the modules of the International Space Station. The dimensions of the International Docking System are the minimum dimension for the modules of the ship. This mechanism is generalized to the entire ship. The payload capacity. We took the SpaceX we consider to load the part of the ship towards the moon, where it will ascend. We design a deployable system for the modules with mobile tracks that will help the transport and assembly of the ship to the lunar orbit. We'll start on the moon. The assembly of the ship will be realized on the lunar orbit. For that reason, must be used a payload ship that will do travels from the Earth to the moon, carrying with it an amount of models on its interior. We have three types of models: small models, medium models, and big models. The access models are designed to be a workspace with different laboratories, like the botanic laboratory. To achieve a centrifugal acceleration similar to the terrestrial gravity acceleration, the models corresponding to the gravity zone are removed 50 meters from the axis of the central ship, and they are rotated at an angular speed of 4.2 revolutions per minute. For the energy, we choose to use a nuclear reactor and solar panels to generate extra energy by converting light into electricity. Here, a diagram to compare the dimension of Artemisa 5 with different elements around the world. Here's a section where you can see the distribution of the modules, the entire ship. This section shows the details: the storage module, laboratory, Martian ship assistance module, botanic lab, feeding station. This distribution is replicated to the other side. Now some different view of the ship. From the top, from the right, from the left. Now you can see the turret and its rate of rotation. And now the dimensions of the models. This is the peak model, and it's useful cubic meters. The axis models, mean it's useful cubic meters. The turret models, and the sleep rooms. Finally, we define 4 colors to help the orientation of the tripulation on the microgravity zone, the ship where the perception from above and below is fixed.
Furnace 1 has a capacity for a crew of 10. It has 24 modules, 2 robotic arms, and 1 operating vehicle. For the propulsion system, it uses a gridded ion thruster. The energy is obtained through solar panels and a nuclear reactor, working alongside the electrical power system and the thermal control system. Here we can see different views of the spacecraft, showing details of the design and how all the parts integrate to form the ship. The design is defined by 2 axes, the central, lateral, and rotating. These last in the artificial gravity zone, while the other are the microgravity zone. The modules are type A or type B. The type A are 6-meter diameter and 9.6 meter large, while type B are 4.6 meter diameter and 9.4 meter large. Here we can see the ship components. Due to lack of terrain, weather, or other conditions present on Earth, we didn't have the restriction to help give form to the design. So, this limit was given by the dimension and payload capacities of the container that will transport the parts of the spacecraft to be built in orbit. For this, we use as reference the SpaceX Starship, with which it will take 20 trips to complete the spacecraft. The chip was designed under the principle of redundancy, which means that it has equipment and supply replacement. The programmatic distribution follows this idea, repeating programs through the chip. Sunlight is fundamental in the development of our circadian cycle. That's why one of the main aspects of our proposal is the design of a lighting system that mimics natural light, changing intensity and temperature through the day. When we were developing the design, we recognized 3 facets of the concept chip, which are vehicle, workspace, and living space, each one with its own programs and requirements, interconnecting with each other. The prolonged lack of gravity for which the human body is adapted causes several problems. To counteract this, we designed the artificial gravity zone, which rotates at 6 revolutions per minute with a 25-meter radius, getting a centrifugal acceleration of 9.8 meters per square second, being able also to adapt to mimic the gravity on Mars or the Moon. The rotational zone is composed of 3 clusters, each one formed by a type A1 module and 2 type B3 modules. Cluster 1 is focused on workspace. Cluster 2 is focused on the health and well-being of the crew. Finally, Cluster 3 is related to the alimentation of the crew. The connection between the central and rotational zone is through 3-axis capsule. Each one has a capacity for 6 passengers. It has 3 internal axes that allows it to turn, minimizing the force difference described by the Coriolis effect. Here we can see some exterior and interior renders, going from the central axis to the different modules in artificial gravity, workstation, control room, sleeping quarters, and so on. Finally, the list of reference we use to investigate while developing the design. Thank you for your attention.
There is an extreme architecture to show us almost totally unknown challenges. Maybe we will never be able to reveal all the mysteries that exist in the cosmos. But even so, we have a space that allows us to think and create, to challenge ourselves to achieve it. Beyond Labels is a project based on the legacy of the architect Galina Balachova and her contribution to the space race, which show us the importance of architecture within the field of the well-being of astronauts. By studying human needs, existing technology, and engineering, we created a spacecraft capable of transporting a total of 10 astronauts on a 3-year journey to Mars from the Moon. Equipped with different areas of development throughout the structure, our prototype is designed to live and work, in addition to considering implements for the exploration and study of the Martian surface.
Okay. Thank you for your attention. I think we are done here. What time is it? I think we don't have enough time.
Now Loreto was requesting if someone has some questions, is available the microphone to, or the hand to hand up and just make the question in case you have for the projects presented.
Okay, many thanks. Congratulations, Valentina, Pedro, and the rest of the team. Outstanding presentation. Well, we have received some queries, and if you have there in the conference room any other question, we may proceed. Well, first of all, we see here some questions. First for Mario. Mario Esquivel, if you are connected. A question, are you aware of other enterprises projecting the use of the same location? That's the first one. The second one, let me tell the three questions and then you answer in the order that you prefer. Yeah, okay. That was the first one. The second, other water reservoir near your location. And the third, do you think that ambient temperature range could be a problem? Please, we have 15 minutes for all the questions, so please focus and go directly to the answer.
Okay. Thank you, Loreto. Thank you, Rodrigo, for your questions. Yes, we are aware of other enterprises projecting in use the same location, especially when India launched some years ago impact the Shackleton crater for finding to search water, but there is no really proof that there is water ice in the bottom of the Shackleton crater. Yeah, RRO Prof of United States made también research about to found or search water beneath the surface of the moon too. But it doesn't, no country has approved that there is really water or ice water on the moon. We must go there to find in situ in the area if there is water or not. But yes, we are aware that our enterprise projecting they use the same location. But we are fine because we know that there are at least 400 impact crater with shadow weight permanently areas. So if Shackleton crater from 20 kilometers diameter will be used by another country or a lot of countries, well, we can move the project to another crater more small, no problem, but must be a permanently shadow weight crater. We choose Shackleton because in Punta Arenas, Chile, all the members have some certainty with this historic person, because Shackleton was an Antarctic explorer, a British Antarctic explorer, who was rescued by Piloto Pardo, Navy Chilean captain, on 1916. So for that reason, we choose Shackleton because we have some certainty, some proximity to this person. Now, but with are there water reservoirs near your location? Maybe it's possible that there is a water reservoirs near our location. In fact, on 2023, NASA will launch a rover to 40 miles from that location to search, search for water. And do you think the ambient temperature range could be a problem? No, because in the permanently shadowy crater in the bottom, the temperature is constant. Because the shadow in the bottom of the crater is constant. Why this is a very advantage to us, because the other projects of UVLF frequency radio telescope project are in the surface of the moon, and the problem in the surface of the moon is that the temperature is not constant, because 14 days there is day, and 14 days there is night. And between day and night, there is a margin of about 200 degrees from 173 minus degrees or below zero, and 150 degrees over zero. So, but in the permanently shadowy crater, in the bottom of the crater, there is a constant temperature about minus 170 degrees Celsius, but it's constant. So it's a very advantage to put a radio telescope inside of those craters. Yep.
Okay, thank you.
Thank you so much.
Very complete answer. Now, Valentina, Pedro, your team. These questions are for architecture team. First question, what kind of rare earth are you expecting to exploit on the moon? Second question, are you aware of not to cause extreme damage to the lunar structure? Are you thinking in robotics, minery as a priority on dangerous environment planets?
Valentina.
I think this question is for Erin, because she is working on the moon, but I think so. I'm working with in there, so I'm searching for anything that are rare earth. I don't know if Erin can respond about the moon.
Okay, I continue. Yes, extreme architecture in moon is with low impact. Yeah? We think that all the structures can be deployed and undeployed from the moon without without a step in the area. We are thinking many robotics mining in moon. No human moon with with a cactus or like this. With rare earths are very little things. Yeah, we think rare earths are the target of this mining. Yeah, and it's not invasive. We are thinking the mining under the moon surface is another thing. Like Mario Esquivel size in this place, yeah, the temperature is constant. Yeah, we have not in this place cosmic radiation. We have not impact of meteorites. We have not a difference of temperature. By this, our experience in Chile in underground mining is very important for the underground mining. Oh, okay.
Good. We have the last two questions. This for the architecture group as well. Would you consider psychological support for travelers during this trip or stay? And the second one is, there are designated landing spots on Mars, or the ship will stay in Mars orbits?
Okay, I can respond. This is the principal thing, no? The psychological aspect is a principal thing of the architect point of view. Okay, we consider three or four things. First, artificial gravity. Yeah, it's not possible a trip for 2 or 3 years without gravity by the impact in the human body. Okay, the second is to respect the circadian cycles. Okay, the light in the day, the light in the night, our rhythmic way of life, no, like terrícolas. The third is the color. All the design has color. The fourth is all the design has a picture from the Earth, that for to be a live in the space with an connection with the Mother Earth. Okay. And the second question is very interesting. Our navies, our spaceships don't landing in Mars. No, it's a spaceship travel from Moon to Mars in the space, ever in the space. And from the ship, we have landing artifacts. What landing and go. It is necessary in the two positions, in Moon and Mars, to have gravity. You cannot stay in Mars 4 years or 3 years with the source of gravity of the Earth. Yeah, you need gravity. It is necessary that the people go to the Navy to have gravity normal. Okay, that is.
Thank you very much, Pedro. Well, this is it. This is our first experience in an international webinar, hybrid system. Some people there in the Chilean pavilion in Dubai, some other here in Chile. We have been pleased to participate. Thank you very much to ProChile, to the Ministry of Foreign Affairs for the invitation to be part of this project of the Space Week in the Expo Dubai. So many thanks for all the audience that had been and stay connected in the Zoom platform and in YouTube. We know that some people is in YouTube watching us, so many thanks for them to be for a long time connected. We expect to have more webinars like this, and of course you are all invited for the fair that is going to be in April of next year, between the 5th and the 10th of April. That is FIDAE, the biggest air and space show in Latin America. So from us in my position of president of the Chilean Space Association, thank you very much, all of you. Thank you, ProChile. Thank you, Chilean authorities there. Thank you, the teams that have been doing their presentations. And well, you are invited to all next activities that we are going to organize in ACHIDE and of course in FIDAE. Thank you very much.
Thank you.
Bye-bye.
Bye-bye.
Okay, I prefer to invite you to see the exposition of 3D spaceships in the stand of Chile. Yeah, now it's there.
You're right, Pedro. People who are in Dubai, they bring some materials, an exhibition that we're going to be able to see there, some posters that are going to arrive soon as of to the pavilion. So you are cordially invited to visit the Chilean pavilion and see the exhibition. Thank you very, very much. Bye-bye.
Until tomorrow then. Thank you all. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye. Stop the recording.